In this video, we'll be peering into the mind of one of the most successful entrepreneurs alive, Sam Altman of Y Combinator and OpenAI, to ask an AI version of him the secret to success. We'll be using LANGCHAIN and OpenAI's language models to extract key tips from his book, How to Be Successful. This tutorial is completely beginner-friendly, and I'll walk you through step by step through the architecture and the Python code where we can chat with Sam the bot and ask him the secret to his success. Okay, so yeah, this is Sam Altman's blog. He published this article, I think 4 years ago, probably before many of us knew who he was. And yeah, it's quite long, but it's entitled How to Be Successful. And in this, he gives a number of pieces of advice, essentially, on how to be successful. So here he says, compound yourself, have almost too much belief in yourself, learn to think independently, etc., etc. But it's quite a long article, right? You know, there's a lot of words here, and nowadays nobody wants to read long stuff. So yeah, so I basically found this article here in a PDF, which is pretty handy. Someone has basically transcribed this here. So this is the PDF that we'll be using today. And what we'll be doing is using LANGCHAIN and OpenAI large language models to basically be able to chat to this document. So we can ask it interactive questions and it can give us back answers in a sort of conversational manner. So you can essentially kind of like have a chat with Sam Altman himself. So this is the document we'll be using. How we'll be doing that? Well, we'll be using an amazing piece of kit called LANGCHAIN. Where is it? LANGCHAIN here. If you haven't seen LANGCHAIN, I really thoroughly recommend that you go through these documents. They've got Python and they've also helpfully got JavaScript, TypeScript docs as well. So yeah, go through that, familiarize yourself, but essentially it is a framework, if you like, for working with these large language models. So it helps you with prompt templates. It helps you with chunking the data into smaller amounts so you don't hit token limits. It helps you with chaining different pieces of technology together. You can interact with vector database. There's absolutely loads to do here. So I'm not going to dive too deeply into that in this tutorial, but I'll definitely be doing more on LANGCHAIN. So subscribe if you're interested in keeping up to date with those, because this is an amazing piece of kit. And yeah, the internet is ablaze with people loving LANGCHAIN, basically. So this is what we'll be using. At this point, I kind of want to take you through a diagram of the architecture, because yeah, if you haven't seen this stuff before, it can be a bit weird. So what we're going to be doing today is kind of in two stages. The first stage is this blue box here. That's the preparation stage. And then the second stage is down here with the user when they're asking questions to the document. So let me just walk you through this briefly. So let's start with the preparation, because that's obviously what we'll be doing first. So we start up here with the PDF. That's obviously our How to Be Successful PDF by Sam Altman. Fine. Then what we're going to do is we're going to extract the text. So from the PDF, pull out the words into essentially a text string, a massive long string. Then we need to split the big long string into chunks. Now, why do we need to split it into chunks? We need to split it into chunks because one of the biggest drawbacks at the moment to LLMs is token size limit. Now, at the moment, depending on which model you're using, there are token limits from sort of 4,000 up to, I think it's 32,000 tokens per prompt for the latest version of GPT-4. But we'll be using an older model because it's cheaper, and we'll be splitting it into chunks of around 1,000 tokens-ish. 1,000 tokens, if you don't know, it's probably something like 500, 600, 700 words, something like that. Okay. Then once we split it into chunks, we will be converting those chunks of text into something called embeddings. Now, I don't know if you've seen this, you may have come across it before, but if not, an embedding is essentially a vector numerical representation of the semantic meaning of a piece of data. That sounds a bit sort of complicated, but it's abstracted away from you quite a lot in LangChain and also by people like OpenAI. But what you can essentially do is you can feed an embeddings model that's offered by people like OpenAI pieces of data. So you could feed it some text, like we'll be doing here. Or you could feed it an image of, say, a cat, or an image of a dog, or a WAV file, or a movie file, anything really. And what it will do is it will semantically represent the information within that document as a long list of floating point numbers. So that's kind of what I've done here. I've said, look, chunks come in and the chunk of text will be converted into these long, weird numbers. You don't really need to understand them, but this is how OpenAI will semantically characterize that information for us. So the vector embeddings, the numbers you get back for a picture of a dog will be very different to a picture of, say, a car, but much closer to, say, a picture of a cat, because obviously a cat is closer semantically to a dog. They're both animals. So that's kind of one of the amazing things about AI, right? So they allow you to do these semantic searches, and that's getting a lot of people very excited. Okay, so once we have our embedding from OpenAI for that chunk of text, what we'll then do is store that information in a vector database. Now, you don't store vectors typically in, your standard databases. So, your SQLs, your Postgres, etc. You store them in vector databases that are specifically designed to store vectors. So big names on the block here are people like Chroma, Weaviate, FAISS we'll be using today, which is the Facebook AI similarity search database. There's a whole bunch of them. Postgres actually also has its own vector database if you're used to working with that as well. So we stick these embeddings into the database, and that completes the preparation phase, right? This blue box. PDF, extract text, split into chunks, turn into embeddings, stick in a vector database. Done. Fine. Now, the next part is, okay, fine. What happens when the user comes along and wants to semantically chat with this PDF document that we've got? So how does that work? So user comes along, user asks a question. How do I be successful? How can I be successful according to Sam Altman? Okay, so what we need to do is turn that question, that string, into an embedding using the same model we did before. So the OpenAI embedding model, it's called ADA. So you can see that here. So it's turned into the vector again. And then we search our database, right, for something that is as close as possible to the information that's already stored in there. So the similarity search is looking throughout all the embeddings and saying, look, give me the point in essentially multi-dimensional space that is as close to the query that we are asking. It then finds the most relevant chunk of text stored in the database as an embedding, and it then essentially sends it back to the user. So we've got the relevant text back. At this point, you then want to pass that here to your OpenAI LLM, or whichever LLM you're using. It doesn't have to obviously be OpenAI, but that's what we'll be doing in this tutorial. You pass that back to the model, you give it the relevant information, and then in a conversational manner, the model will reply back to the user. So that's kind of the whole process flow of what we'll be doing in this tutorial. Hopefully that was helpful. and it's clear. But if not, I think it'll be a lot clearer later. So let's just jump into the code. So what are we going to be doing here? We are going to be using a Google Colab notebook. Now, if you've ever used Jupyter notepads before, it's basically a cloud version of Jupyter notebooks. So kind of similar to what Google Sheets did for Microsoft Excel. I put them in the cloud. Google Colab Notebook has done for Jupyter notebooks. If you haven't used Jupyter notebooks, basically it is a cloud-hosted dev environment where there's a whole bunch of pre-installed software and dependencies, so you can get up and running really, really quickly. There's no complicated dev environment setup, which is particularly helpful for newcomers, and yeah, it allows you to get into things quickly. So I'll leave a link to this notebook in the description, and then what you will be able to do is, once you click on that link, you'll be able to go to File, Save a Copy and Drive here, which will save a copy of the notebook into your Google Drive. So once you've done that, you will be able to do any edits you want and to run your own code, upload your own documents, etc. It's your code, you're free to do with it what you want. So let's just run through this and I'll explain each piece of code step by step. So the way that Google Colab notebooks work is they run code in isolated cells. This is the first cell, this is the second cell, this is the third cell, etc. So the first cell will just run by clicking on this play button. What we're doing here is we are installing all of the dependencies. We've got LANGCHAin, OpenAI, PyPDF2, FAISS, however you say it, the vector database, and something called tick token that you need for the OpenAI embeddings. So this will take a little bit of time, just let it run. You can see it's spinning here. It's all running on Google's machine, so it'll be relatively quick. Yep, here we are, 24 secs. It's done because of the little tick, right? You can see that there. So when it's done, we can move to the next cell. Here we are importing the pieces of, or the relevant modules, or the relevant parts of those packages we've just installed. PDF reader, OpenAI embeddings, character text splitter, and the vector database. Then we need to get our OpenAI API key. If you don't have an API key, just Google OpenAI API key. Yeah, come here, sign up if you haven't already, create a new key by clicking Create New Secret Key, copy the data, and just paste it into your Colab notebook here. So this is my key. Obviously, I'll be deleting that after the tutorial, but you paste your own key in here. If you sign up now, I think you get 18 bucks of free credits, which is quite cool. It's like a promotion, so yeah, do it today, get the credits, have a play around, because I'm pretty sure it will become a paid service shortly. Then what I do here is we load our Google Drive, because that's where we'll be storing our PDF document. Let's just load that. I've already loaded mine, but when you load yours, a pop-up window will come up on display, and it will ask if you give it permission for this notebook to access your Google Drive. So just click allow, give it permission, and then move on. Just to give you an overview of my Google Drive. So I'm storing the document here in my drive, Colab Notebooks, YouTube. This is the document that I showed you earlier here, how to be successful. That's this. I've called it altman.pdf. So in our notebook, on the next cell, what I'm doing here is I am loading in that document into our instance of PDF reader. so that we can extract the text from that PDF. Just on that point, actually, make sure any PDFs that you have are not just images. If they're just images, you won't be able to do this. How do you know if it's an image? You can just Control F, try and search for something. Like I can see here, there's the word extreme. Let's try and search extreme. Yeah. So you see how it found it? It's even found more instances. If you can do that, you're fine. If you can't, it means it's just an image and you won't be able to search the PDF. You have to find, you know, one that isn't just an image and that is actually storing the text itself. Otherwise, you can't extract it. Well, I guess you could with like an OCR or something, but not using this technique that we're using here. Okay, so the next thing we need to do is read the text from the PDF. So here we are extracting the pages. We're looping through each page in the extracted, in the PDF document, page by page. We're looking for text. If there is text, we're then adding it to this empty string called extracted text as we loop through. So that we were going to have one massive long string called extracted text at the end with all of the text that's contained within the PDF document. Let's just check that worked. So we can print out the first 500 characters and you can see it's working. How to be successful, Sam Altman, etc., etc. So that's great. Then, where are we? We are, yeah, let's have a look at this. We're here, right? So extract the text. We now need to split into chunks and then we'll turn it into embeddings. So let's split it into chunks. Here we are splitting it into chunks of 1,000 characters with an overlap of 200. Let's run that. I don't know why I'm getting this error, but it seems to work okay. But yeah, I'm just ignoring that for now. And it's worth actually just pointing out that all of this stuff is just coming from the LangChain docs, right? So here is the text splitter code that we're running here. And a lot of what we're doing is actually coming from this. Questions answering, not with sources, questions answering, this page. Yeah, here. So a lot of what we're doing is just coming from here. So read the docs if you want to get more up to speed. So we have our chunks. Now let's see how many chunks we've got. We've got 14. Let's just randomly look at one of those chunks to make sure it contains information that we expect. So this is the 5th chunk. The 5th chunk contains this. That looks good. Okay, so now we need to get our OpenAI embeddings. So let's run this cell. Now we need to save the embeddings to our vector database, FAISS. So let's do that. Okay, so that is the prep stage done. Extract the text, split it into chunks, get the embeddings, stick it in the vector database. Done. Now let's work on the next part, which is taking a user query, turning it to embeddings, searching for the relevant chunks of text, getting those back, passing to the LLM, passing it back to the user. Okay, let's load in our LangChain Q&A chain, which is from here, question and answering. Have a look at this. I'll leave the description, the link in the description. But yeah, this is where I'm getting this code. And now, excitingly, we are ready to start asking questions. So this is all about trying to find the secret to success, according to Sam Altman. Okay, so let's ask him. Okay? What is the secret to success? That's my query. We'll then search the document and then pass it to the LLM. So let's do that. Great, so it worked. The secret to success is to focus on areas that are important to you and work hard to achieve excellent results. It is also important to have the right motivations and to believe in what you're doing. Working hard at the beginning of your career is particularly beneficial, as you will have more time to see the results of your hard work compound. Finally, it is important to be bold and be able to convince other people of your vision. Okay, sound advice. If only I'd listened to that. Okay, here's some other questions. Give me some more tangible advice. What are 3 key steps I can take today to be more successful according to Sam Altman? Let's run that. 1. Make it easy to take risks by looking for small bets that you can make to potentially gain a lot. 2. Focus your work to be a force multiplier. 3. Develop self-belief and get good at sales by believing in what you're selling and practicing communication skills. Okay, nice. Give me more tangible steps to get better at sales. Yeah, okay, let's run that. Practicing communication skills using plain, concise language, believing in what you're selling, showing up in person when it's important, and getting better with deliberate practice are all steps to get better at sales. Nice. Should we try one more? You can just click plus up here. You can add a code block. Let's just paste that in and change the question, obviously. What is the worst thing I can do that will stop me being successful? Let's run that. Give up too early and not push hard enough. Okay, so yeah, there you have it. All you need to do is focus on areas that are important to you, work hard, particularly in the early part of your career, believe in your vision, get good at sales, and not give up too early. There you are. Lovely. I hope you found this one helpful. If you did, please consider subscribing so I can make more videos like this. See you in the next one.